Let's do an example. Find a function f such that f prime of x is equal to 2x minus 3 and such that f of 5 is equal to 3. Now, this type of problem is sometimes called an initial value problem. And what we're really trying to do is to find an antiderivative of this function, 2x minus 3, that satisfies this condition, f of 5 is equal to 3. So, how do we do that? Well, to get an antiderivative of 2x minus 3, we're going to do the integral of 2x minus 3 dx. And that integral will be 2x squared over 2 minus 3x plus c. And we can simplify this to be x squared minus 3x plus c. So our function that we're looking for, our f of x, has the form x squared minus 3x plus c. Now the question is, what should the c be? Well, that's what this condition tells us. This is sometimes called an initial condition. We want f of 5 to be 3. Well, what is f of 5? Well, f of 5 is 25 minus 15 plus c, right? If we plug in 5, and that simplifies to be 10 plus c. Well, notice we want the f of 5 to equal 3. So we want 10 plus c to equal 3. So we solve this 10 plus c equals 3. And if we solve this by subtracting 10 from both sides, we get c is equal to negative 7. So what is our final answer? Our final answer is f of x equals x squared minus 3x plus c. But what is c? C is minus 7. So we could put plus minus 7, or we could just put minus 7. So this is our function that satisfies both of these conditions. Notice we can check our work. What is f prime of x? Right? F prime of x is 2x minus 3, right? So we found our function f of x such that f prime of x is 2x minus 3. And you can check that f of 5 is equal to 3. Plug in 5 here, and you'll see you end up getting 3. Let's do another example. Find a function f such that f prime of x is equal to this, and we also want f of 9 to equal 17. Well, let's rewrite this. This is 2 over x to the 1 half power, or in other words, this is 2x to the minus 1 half power. So let's do the integral of that. What is the integral of 2x to the minus 1 half dx? Well, the integral is going to be 2x to the, well, we have to raise this power by 1. So if we raise negative 1 half by 1, we get positive 1 half. And then we divide by 1 half, and then plus c. Well, dividing by 1 half is like multiplying by 2. So this is really 4x to the 1 half plus c. So that's our f of x. F of x is 4x to the 1 half, or 4 times the square root of x, plus c. Now, what is the c? Well, that's what this condition is going to tell us. So we need to plug in 9, right? F of 9 is equal to 4 times the square root of 9 plus c, which is just 4 times 3 plus c, which is really just 12 plus c. And we want 12 plus c to equal 17. So c is equal to 5. So what is our final answer? Our final answer is our f of x is, well, it was of this form, 4 times the square root of x, or 4x to the 1 half power, plus our c, and our c was 5. And you can check if you take the derivative of this, you get this, okay, if you simplify it. And you can also check that f of 9 will be 17. If you plug in 9 here, you're going to get 4 times 3 is 12, plus 5 is 17. So this function solves that initial value problem. Let's do another one. Find a function r of t such that dr dt, right, the derivative of r with respect to t, is equal to this, and such that r of 3 is equal to 79. So let's rewrite our initial function. We can rewrite it as 36t to the negative third. And so our r of t is going to be the integral of 36t to the negative third dt, which is going to be 36t to the negative. Now, is it negative fourth? No, right? It's negative 2 over negative 2, right? We have to raise that power by 1. When you raise negative 3 by 1, you actually get negative 2. And we're going to put plus c. Now, the 36 over 2 is really just 18, and we still have this negative, so this is negative 18. And this t to the negative 2 on top can become a t squared in the bottom. So that's our function. Our r of t is equal to negative 18 over t squared plus c. But now we need to use our initial condition here, r of 3 equals 79, to find c. Okay, so r of 3, what is r of 3? Well, it's going to be negative 18 over 3 squared plus c. That's going to be negative 18 over 9. That's negative 2 plus c. And so we want negative 2 plus c to equal 79. So add 2 to both sides, we're going to get C equals 81. So our final answer is not 81, right? Our final answer is that R of t is equal to negative 18 over t squared plus our C, but our C we found was 81. And you can check that this satisfies both of these conditions. The derivative is going to be 36 over t cubed, and R of 3 will be 79. Now, our last example is also an initial value problem, but it's stated in terms of a cost function. Find the cost function if the marginal cost function is c prime of x equals 8x minus 6, and the fixed cost is 19. Now, remember, the marginal cost is just the derivative of the cost function. So to find the cost function, we have to integrate the marginal cost function, right? Integrate c prime of x. So we're going to get the integral of 8x minus 6 dx, and that's going to equal 8x squared over 2 minus 6x plus. Now, I could put plus c, although we're using c for something different here. So maybe let me just call it k here. I guess you could call it c as long as you're able to remind yourself it's not the same as this c. But notice how this simplifies. This simplifies to be 4x squared minus 6x plus k. So that is our c of x. Our c of x is 4x squared minus 6x plus k. Now, what is k? Well, here we're told that the fixed cost is 19. And remember, the fixed cost happens when x is 0. What's the cost when you produce 0 items, right? And that would be $19. So c of 0 is 19. That's what this condition tells us. C of 0 is 19. So what is C of 0? Well, C of 0 is just going to be K. In fact, this number on the end here is always going to be the fixed cost. So this is really 0 minus 0 plus K, right? So that's just K. C of 0 is going to be that K, but we want C of 0 to be 19. So in other words, K is just 19. So our final answer is C of x equals 4x squared minus 6x plus 19. So that 19 you can see is the fixed cost. That's the cost when x is 0. The number of items produced and sold is 0, right? C of 0 would be 19.